Morning, everybody. I'm also going to do the walking around thing. My ADHD sometimes gets the better of me. So Johan asked me to just come and chat to you a bit around what Red Hat is doing in the world of AI. And we've seen a lot of stuff. And I thought I'd take a bit of a different approach. But on a side note, Johan, this is the first time I've seen a presentation where I felt the earth moved. Okay. Right. It's the construction downstairs, but you know, I thought I'd leave that out there. So I think we are going through a bit of AI fatigue at this point in time. As Michi mentioned, you know, there's the Gartner or the analyst police that make sure that you mention it in every slide deck that you see today. And unfortunately, we're not going to be any different from a Red Hat perspective. But what I did think of doing is rather throwing a bunch of stuff at you. All right, let's break this down into how do we make this a bit more useful. What does it really mean? Because I think a lot of folks have interacted with AI, whether it's been through the simple AI generated results in Google these days, or you've got a Claude or a Gemini or something on the desktop, and yeah, and they're quite interesting to chat to, depending on what you ask those bots. Okay, but we stuck pretty much all the hype is in the world of the bot, right? And this ability to interact with them. But if we break down the discipline, and this is going to be a bit like speed dating for IT, right? Because we're going to try and distill 40 years worth of research, starting with Alan Turing all the way through to some of the great minds of today, and just what this means to everybody. Now, we're looking at this wrong, right? Let's take the letters and let's make it useful. Okay, if we turn them around into IA, okay, this is what we should be thinking about. Now, what is this acronym? Okay, intelligent automation. Right, AI and the tools and the capabilities that we've developed is unlocking this ability for us to intelligently automate the system. And it's built on a couple of things, right? The capabilities that have been developed in AI are really what are going to enable that intelligent automation future for us. Now, one of the first things, you might have seen this before, models today and of the great tools, and if you think about what the chatbot does, okay, they've become incredibly good at natural language processing. So let's use that. Okay. AI unlocks this ability for the computer, whether it's yours or whether it's one in the cloud or wherever, it allows it to reason. So it's a reasoning engine that we get out of this new capability. Okay. We've got this idea of retrieval augmented generation where, you know, the first bots, the first iterations of the ChatGPTs out there and the Geminis and whatever, you were pretty much restricted to the knowledge that was contained within that incredibly expensive model, okay, that they burnt immeasurable amounts of forests to produce, okay, but that's it. Whatever knowledge was in there, we were stuck with. And for the guys that have used these things for coding, I've got news for you. You're not creating anything new, right? Anytime you get a piece of code out of AI, it's legacy code. Let's just think about that for a second, right? It's somebody else's code, okay. But this last one is the one that excites me the most, right? So this is where we're starting to move over the top end curve of the hype cycle, and we're trying to figure out how do we do things that are useful. And one of the things that is emerging really, really quickly is this idea of the model context protocol. Okay. So what does this mean practically for us, right? Natural language processing gives us the universal interface. It means that we no longer need to think in terms of the computer and the language the computer understands. We can use our natural language to interact in a universal way with a system, okay? This is going to allow our systems to recognize, understand, and generate our language. And the idea is that we can get to the point where we bridge human intent, okay, and machine execution. And we'll build out a bit of an example later of how this could work, right? But what it does do from a turnaround time is we're eliminating complex user interfaces, you know, forms, all of those things that the guys that had to build them, front-end developers, whatever. Honestly, we don't need them anymore. And as speech recognition gets better, we won't even need to type. So those like me who don't really spell all that well, okay, we can just converse with this system and give it our intent. Okay. Now the reasoning engine is where the really exciting part gets. Now I spent the better part of 20 years building enterprise application integration and BPM systems, business process management. Okay, and the big thing that held us back in there is that all of those constructs are still machine or was in the world of the machine, right? Everything came down to a simple statement of an if then else. If this condition is true, then do this, otherwise do something else. Okay, and this is how we've built software. For the last 40 odd years, software has been built around these conditional statements and constructs. Okay, now if we build an automation system, or if we want to automate anything in our business, we can go and build a bunch of these if then else constructs, and most modern software still works around that notion. Okay, but we can't account for every edge case. Now if we swap that out, okay, with a reasoning engine that understands our natural language, and we can guide it and provide it input, continuous input in a way that is comfortable to the human being, right, into this reasoning engine, we completely change that construct. So we go from this very rigid if then else, okay, into a system where we operate at that level of abstraction, meaning that, okay, I don't need to model every scenario. The reasoning engine can analyze, decide, and act on this. It's kind of scary, right? If we go back to that last one, Skynet's coming, the computers are coming for us. But this is what we get with these models. This is what we're getting for the thousands and millions of watts that we've burnt creating these neural networks inside of models that we can execute. Okay. The thing with that is, as I mentioned before, the early stage, we were pretty much constrained to what that model was trained on. So whatever somebody's opinion was of data that needed to go into that, that's sort of what you got. Okay. Now, very early on, you would have seen a lot of press about, oh, okay, but this thing is spitting out complete nonsense, AI hallucinations, as they call it, or it's creating copyrighted works and things like that. That creates a whole new world of trouble. Now, things like retrieval augmented generation, which is this capability being added in the space, allows us to take these things and ground it in a bit of enterprise reality. Right? Now we can take some of this great stuff that our friends from Atlassian discussed earlier this morning, right? Where they've done this, right? A lot of this, the Rovo capability, being able to look into that enterprise data and provide additional context and ground the actual reasoning engine in that reality of what is happening in the enterprise, will give us that ability to respond and reason and decide accurately using these models. Okay, and then that allows us to transform these general purpose models, or as the industry likes to call them, the foundation models, into specialized and reliable enterprise tools. Right, so we can start adding some guarantees. And now I feel the earth move again. Okay, and then the last part of this, the missing piece in the puzzle up to now has been this universal connector. Because if you've worked with things like ChatGPT or Claude or Cursor or whatever, until recently you would have seen that they still isolated. You're still actually in that little sandbox, and you can plug in some data into a model that you maybe run yourself, and now it can tell you about, okay, what's the hiring policy based on my HR procedures or something like that. Okay, but how do I get this thing to do something really useful in the environment? And Model Context Protocol allows us to do this. So we can have these different AIs, these siloed AIs, we can now bring them into a single fabric. And each one of those agents can then expose to the reasoning model a set of capabilities that it provides. And the model can make a decision on when to invoke one of those agents to get a result or do something meaningful. Okay. Now these things come with challenges, because this is now where we are at in the industry. So we've just done the 40 years worth of evolution. It took us 35 just to get to complex models, and it's taken us just 5 years to get to the rest of it. So this is accelerating unbelievably fast for the industry. The challenges as an enterprise organization today, if you're not at the cutting edge of research or you don't have a Google or Grok whatever budget, okay, you're pretty much stuck into this reality. And the first one is cost. Okay, this generative AI frontier is exceptionally cost prohibitive, right? It's not like anybody can go out unless you've got that, who's got the unlimited budget here. All right, you can drop it on 10,000 HS100 NVIDIA cards. Okay, it's not going to happen. So we have to figure out how to do this economically and sensibly in the enterprise organization. Now, we've looked at this at a very high level, but if you drill down and you open up the kimono a bit, you'll see that there's an unbelievable amount of complexity in terms of actually standing up these systems. So that is a barrier to entry on that. And the last thing is control. It's all great to say, okay, we can do all of these things, but how do we actually just keep it on a leash, right? And control might be, how do we maybe make the model safe? How do we make the interaction safe? Or how do we contain the costs so that they don't sprawl out of it? Okay. And these are the challenges that, as Johan says, we have the privilege of speaking with a lot of customers. And this is sort of the consensus that's coming back from everybody. It's like a lot of folks went head first and saying, like, I'm going to do AI. Great, you built a chatbot. Okay. We've had those. Actually, you know what? Your chatbot's quite annoying. Okay, I'll be honest. Who's at the point where you actually go away from a website the minute you look at something and this little thing pops up on the bottom right-hand side? Yeah, me too. Count me in. It's annoying. It doesn't really add a lot of value because that chatbot doesn't necessarily have a lot of context about you. Okay, so guys, if you are doing it, please stop. Okay. So how do we address this? Okay, and Red Hat has been an organization that has built platforms for a good 30-odd years, Michi. I still actually owe you the 3.5-inch disc, the stiffy disc. Anybody remembers those? I've still got one branded by Obsidian on one of the early releases of RHEL. I must give it to you, or we must frame it up for you. But we've been building platforms for a very, very long time. And what does it mean to build a platform? It means it gives our customers a set of tools for them to innovate on. We're not going to solve your business problems. We're not going to give you specifically tuned models or anything like that. But we're going to give you a comprehensive tool set that is reliable, vetted, okay, and performant to build these innovations on. And this is what the Red Hat AI platform is all about. Okay, with the focus on that 4 key areas that is important for this, right, is being able to efficiently provide inferencing. We spent a lot of money acquiring an organization called Neural Magic at the beginning of this year, and these guys are rocket scientists, right? They are some of the folks that are at the cutting edge of this research, and they have done some amazing work around figuring out how to run these models, these 20 billion, 104 billion, whatever parameter models that know everything, okay, how to run that very efficiently, okay? And there's magic that I don't even know about, things like quantization, changing floating point, all of that. There are people way more cleverer than me that can tell you about that if you want to know more. But the net effect of that is that you can run these things much more efficiently on commodity environments at the end of the day. The other part that the platform addresses is this ability to connect the models to the data. As I mentioned before, how do we ground these things and put them into context of our organization through that RAG, retrieval augmented generation? Okay, you're going to need some tools to feed these things with data. Again, there's a lot of it out there. Like a lot of what we do as Red Hat, we take the best of breed, we package it up, we test it. Slightly opinionated sometimes, but we know it works at the end of the day. And this helps us then accelerate that agentic AI adoption and deployments and be able to roll those out fast. And the last thing is, if you've been watching this show, right, over the last couple of years, what we've been doing with OpenShift, one of the key messages has always been that technology needs to be completely hybrid. You might start out in your data center today, but you want to scale and use somebody else's computer in the cloud. The way you do that doesn't change. So being able to deliver AI tools and capabilities irrespective of where you are. Okay. So with fast, flexible inference, this is really the secret sauce in a lot of what we do on this platform, right? Um, Today, from an AI perspective, I think most of AI capability is dominated by one vendor, being NVIDIA. They definitely have the monopoly at this right now, and yeah, you can't buy a GPU for love or money these days. Okay, but they will not be in that position for very long. Okay, and from an inference platform that we provide as Red Hat, it allows you to do any model, any platform, any accelerator. Right. This is the power of the platform. So don't get tied into a single vendor's ecosystem. It's always been about choice on that. Right. And the key technology that enables that is something called VLLM. This is the work that Neural Magic was doing, those really clever guys, and they continue to do. And they have been working to provide a harness that runs any one of these models, whether it's a DeepSeek, a Qwen, a Llama, Google models, whichever one. Majority of them have been optimized to run in VLLM and be able to run them across any type of accelerator, right? So that complete abstraction. This is some really great stuff. Okay. Okay. But again, pretty much the same thing. Just to add here, again, we do this in a hybrid fashion. Right? So all of that goodness, okay, anywhere you want to be, whether it's physical, whether it's virtual, private or public clouds. And even at the edge, right? A lot of these things are going to become really, really interesting for people like retailers, manufacturers, but being able to do very fast, efficient inferencing at the edge. So on the shop floor, in the manufacturing plant, down in the mine, wherever that might be, have a consistent platform to actually do this with. And your management paradigm remaining the same. Okay. As I said before, without these things having any context of your data, they're pretty much useless, right? You might as well just spin up ChatGPT on a web page and try and make sense of that. It doesn't know anything about your... the Red Hat AI platform provides us with the tools to ingest the data, okay, and create those processes and pipelines for building data sets that we can line these models with and ground them in our enterprise data on that. What's very interesting here is your data scientists, okay, or let's rather say is that this has been the purview of data scientists for a long time. Now, again, Michi, you and I are old enough to remember that before they were called data scientists, what did we call them? Actuaries. Yeah, okay, same thing. But not a lot of organizations can afford to keep a team of data scientists on there to align and tune with these models. And we've enabled the capability. We've worked very closely with IBM. And IBM have got a very, very long history in this world of AI. They were the first guys to beat a chess grandmaster at his own game using an AI a long time ago. And this idea of synthetic data generation actually, to me, is the way that we democratize the tuning and alignment of models. So now we don't need to bring in the data scientists to create these weird and wonderful models and numbers and sets of numbers. We can bring in subject matter experts, right? So if you're in the insurance business, your senior assessor can write a set of assessing rules for doing claim resolution. And you can use that to synthesize data to align these models into what it is that you're trying to achieve with them, like automated claim processing, for argument's sake. Okay. The platform also allows us to deploy the frameworks that enable MCPs, right? The Model Context Protocol. Again, if you look at the plethora of tools out there, one of the things that's a barrier to entry for a lot of people today is just choosing the tool. Okay, will this work with whatever I'm trying to do? Can I do MCP? Can I do a quantized model? Can I do an 8-point floating bit model? Whatever. Like, we take away that complexity and we create this engine whereby you can actually add in these MCPs. So an MCP server is this thing that it acts like the coordinator between the reasoning model and all of the great agents out there that you might be building on that. Okay. So that's it. I've paid the bills. That's the product. If you want to know more, okay, we can have a chat afterwards. Let's do this in real world. And then I like to see how things could actually work. And I go back to a quote, famous scientist, so those of you who are into science, Richard Feynman, one of the greatest minds of this century. The last thing he wrote on his blackboard before he passed away was, what I cannot build, I cannot understand. Okay. So if we build something, it helps us to understand and put these things into effect. So we're going to do a simple use case, right? We want an automated, intelligent incident response system that allows us to interact with our external Jira service management environment or ticketing system, but we want users, operators to interface with this thing using good old-fashioned English, right? Okay, now why is this important? Okay, because that skills issue that Johan has been talking about, sometimes people understand the environment really, really well, but they don't have the experience to express it in the specific technical terms in order to do that. Okay, so being able to interact with a system in that natural language is going to be immensely powerful, all right? And in this example, we'll start with a human-centric interaction where somebody notices, hey, there's a problem. Okay. So we look at this. How do we do this? Phase one, the incident reporting and triage. Operators got seeing some stuff acting a bit weird. Now in OpenShift, we've enabled OpenShift with something called Lightspeed, where you can, in natural language, interact with an OpenShift cluster, okay, and ask it questions, and it can go find out things for you. Okay, so the operator notices a problem that one of the apps is running slow, and the assistant guides the operator to do a couple of things in the console, provide the input, okay, and it diagnoses the problem on that. Right now, this exists today. This is something that you can do. You can go and deploy OpenShift. You can deploy Lightspeed, and you can have this interaction. Okay, and that thing might find that, oh, okay, I've got a database environment that's kind of dying. For whatever reason in production. Okay, so Lightspeed gives that feedback. Now it gets interesting, right? For those of you who've been in the world of Red Hat a bit, you'll know we've got this great service called Insights. Well, recently we actually MCP enabled Insights as well. So MCP now becomes an agent, okay, that you can plug into this reasoning engine. Right? That agent is noticing, hey, but I'm seeing this trend on the system, right? I've got this pod that's dying and getting started and getting created and all of that. Okay, it looks at the trends, it looks at the logs, it looks at the metrics it gathers and says, hang on, I know what's happening here. Okay, I can make a recommendation, all right? And that recommendation is reported back to the user in a real world, but also in the form of a prompt. Now we can take that prompt and we can pass it onto a process in our Ansible automation platform. Okay, and that automated process gets triggered, and as part of this, we leverage the MCP enablement in our Jira system because now we have knowledge of what we can do in the Jira environment, and we do the right thing, right? We've trained this, and the system knows that, okay, our corporate policy says we don't make a change without a ticket and some sort of change control. We create that ticket in the environment, and we actually provide that input from Insights into the Ansible Lightspeed that Johan showed you, and it starts generating a playbook. Okay, so at the same time, it creates the ticket, it's put context around the ticket, it provides the description of what's happening in there, and the full recommendation and the remediation list of that. Right, so this is stuff that everybody's probably done 100 times before. Pick up a ticket. Okay, what's wrong? I got to go check logs. Day later, maybe let's do this, right? Okay, this we've probably done in a matter of minutes at this point in time. Okay, but we also know from the knowledge in our RAG system, because we've created this idea that our reasoning engine is grounded in our enterprise knowledge, we know that we cannot just make a change to production. Okay, well, most of the time we can't. We shouldn't. Okay, so we have to follow some sort of process. The ticket is captured, and the tracking starts throughout the remediation process. Okay, That recommendation that Insights gave us, we can pump into the Ansible Lightspeed AI, and it will generate a very high quality Ansible playbook, because the Lightspeed for Ansible has been specifically tuned to understand the context of Ansible. Okay, and it's built on top of best practices, playbook creation rules that Red Hat have honed over the years on top of that. So you get a good piece of that. Brings that into the Lightspeed. At some point in time, it says, okay, I know I can't just go and do this. I need a human, the OI, the organic intelligence, to review what we're going to do and say, okay, go, no go, or at least there's a change window coming up tonight. Let's wait for the change window and push the button. Okay. And then finally, closing the loop, okay, that playbook is launched in the Ansible automation environment, and that goes and patches this, the application on the OpenShift platform. OpenShift does what it does and says, okay, I'm a deterministic system. I've seen the patch. I'm going to redeploy, and then I'm going to close this out by making sure that I have removed that kill operation, that resource constraint on that. Okay, and once I can validate that from the reasoning engine, update the ticket, close the ticket with the evidence of what was done. So attach the playbook, attach the results, close the ticket, go home, have a beer. Okay, and this is a hypothetical, but all of that's there today. We're hoping to actually build a really good demonstration of this quite soon, because I think it would be really impressive to go through that remediation. So now you can talk to your cluster, be nice to the cluster, okay, and resolve issues. And that's just a taste of what we're doing in the world of Red Hat with our AI. So thank you very much for your time. I hope I didn't go over too much on that. And yeah, as Johan said, I was nice. No chatbots were harmed in the production of this presentation. Thank you, everyone.